All right, welcome. I hope you all had a good lunch. Before that, we heard Steve McMahon talking about Plone deployment stuff, and I'm actually pretty happy that he already mentioned a lot of the Plone specific and Zope specific things, because I'm going to talk about all the stuff that goes around it, on top of it, below it, next to it. And so that's not going to be very Plone specific, but a lot of stuff that feeds into the environment and what Plone can benefit from. I will have a lot of pretty strong opinions and might do some things different than you do. Yeah, you got to live with that. So I come from a company called Goscept, and we're pretty small. We're 13 people by now. We exist since October 2000. And when we started, that was around the time when the first internet bubble was about to burst, and so we were lucky to not have any money back then. When we started, we would do pretty much anything that people would pay us to do, like PHP shit and selling servers and stuff like that. It's just to pay the bills. And over time, and in parallel, we also did our computer science studies. The projects grew, and we grew with them. And today we're a service provider. We don't necessarily do Plone, but Zope and a lot of Python stuff. And we run projects for lots of large customers in Germany. And we spend a lot of time focusing on the software and the methods we use to build the software. And we're very open source driven. We don't do, I think, anything that is closed source. And so we're pretty happy with that. Unfortunately, there was another small part of our business that we always did on the side, and that's what you would call hosting. And a few years ago, that's probably in 2008, we realized that what we did in hosting that wasn't really attractive to us and the customers. We just always needed something to have the software run because we build it and then we want to maintain it, and yeah. We didn't really invest in the servers, in the infrastructure, or did a good job regarding support, and we sat there and we thought we got to change that. And so actually, you can see shirt, that's pretty new. We created something, go back. Why do you do that? Go ahead, ta-da. So that's the thing that we focus our attention on right now. It's called the Flying Circus. You might recognize the name. And so we sat down and we said, okay, all that nitty-gritty stuff that we do and we have to do, let's turn that into something where we can focus. And nowadays you would call that a DevOps shop, except that didn't exist when we started out with that. Actually we managed to arrive at a point where what we considered unattractive and badly done about 4 or 5 years ago to be pretty nice for us and for our customers. And I'd like to reflect on how we got there and just show you what our decisions were, what the stuff is that we have to deal with to get to a point where we can say, hey, we're pretty happy running software. So as I said, we are working for a couple of pretty large companies. If you know the German market, these are pretty big ones, or internationally, Star Alliance, for example. And we got pretty good feedback from these companies where we think we're just doing our job, and that seems to be the baseline to be praised for. So in general, IT and operations seems to be in such a bad shape for these large companies that just by doing your job, you're already like better than everybody else. So I extracted this talk from actually two projects that you can see here. The European Agency for Safety and Health, they're running a big Plone site that's actually developed by Syslab. You can raise your hand and wave. They're a sponsor here as well. And Star Alliance, who also run an intranet for how many thousand people? 6,000 active users. That's a Plone 4 site. And so from these two projects, that's where I got the specific project experience from, and obviously our internal stuff that we do to build that environment. So what does a Plone environment look like for us? Basically, there's almost no, it's like the smallest thing. That's the Zope server. That's almost the production setup of the European agency. They just got an update a few weeks ago. It's changed a little bit. Something that changed today is that Deliverance doesn't run over here anymore. Deliverance moved into each Zope server, just as a side note. What you can see is that your actual application, what you do with Plone is actually basically sitting in here, but you rely, and in most of these big projects, you're going to rely on a quadrillion, about like one or two less, components that run next to it, on top of it, around it, and you somehow got to take care of all of that. And what happens when you're the operations people, because we're doing the operations, Syslab's doing the development, is that they come up and say like, yeah, we've got to use open LDAP, and you're like, okay, another package, and oh, Postgres, and like, ooh, okay, and you can say, okay, I can give you LDAP, open LDAP 2.4, but I don't promise which minor version, and we're going to compile it with this. And there's this going back and forth between development and the operations that we think needs to be smoothed out. This is the long-running problem between in IT, where you develop a project and in the best case you hand it over to admins that then run the thing. Basically that's what mostly is called throwing it over the fence. Like, okay, here it is. Here's what I built. Now you run it. And we want to change that. We want to stay in constant interaction with the developers up front to know, okay, they want to run this and they want to LDAP, and we're going to say, hey, be careful because the LDAP thingy is really complex and you might want to use that version of this thing. So we want to integrate the operations people all the time during development. And so what we do is we split our thinking into in three different parts: infrastructure, platform, and the application. And I'm going to talk about the details right now. So the first thing that we do is infrastructure. That's like the groundwork to build everything on top on. It's nothing that you want to see as an application developer. And the question is, what is infrastructure? And infrastructure basically is there to marry software with entropy. As a developer, it's really easy to have your environment come to clean slate. You just run your tests, and the tests always run in a very clean environment, and they show that your software does the right thing. And you can always start fresh. In operations, you start fresh once, if you're lucky. And then you never go back to that state. You can have a bug in your software, and the developers will fix it, but half a year later you notice that there's still like 4 database records left in your database that have some consequence from the bug from half a year ago. So basically, entropy is what infrastructure is there to deal, what infrastructure's main task is to make it bearable that you have entropy and make it manageable, so that you as a developer don't have to reinvent the wheel all the time trying to deal with that. The infrastructure is building a platform in our case. So we use it to deal with entropy, but we also at the same time take all of those things that are infrastructure tasks and bundle them into something we call a platform. That's the blue stuff there, and you can see that there's some bluish, greenish stuff. The green stuff would be the actual application, because it's not a hard limit. There's stuff going on the process level. So the processes that handle ongoing things, they both go into the application level and the infrastructure level. And obviously, you use some stuff that gets installed on the infrastructure level, but then needs customization for the specific application. What we want in our thinking is that we use infrastructure, technology, and processes. That's the technology, that's the processes, to build something where the application developer can rely on, expecting that these problems are all already solved. This isn't even to say that you should be using our platform. It's if you're thinking and operating stuff, then you should try to think in these steps and these layers yourself. So, for example, if a developer comes to you and says, "Hey, I need a new box," then wrong question. You're barking up the wrong tree. The developer should say, "Hey, I need these components to be run. What's a good way to do that?" And then you, on the platform and infrastructure level, figure out how to do that with the tools you have underneath. So the first thing that comes into infrastructure here is the data center, and we actually choose to not do that. We just buy that. Our customers like that we do have tight control over most of the aspects, but we don't want to actually create buildings. We don't want to do physical security. We don't want to do air conditioning or power or backbone networking or the hands-on support or put the racks in there or stuff like that. So we just go to a data center and we found a really nice one. We like these. We're friends with these guys, and their standards to make sure that that you can that they are actually reasonable. They just recently got an ISO 27K certification. That's kind of the one thing that you want to look out in a data center for. If they do that and they're also nice people, then that's a good combination. So the data center is something we take for granted, where we have our standards, where we expect what's going on. So the next thing that we need there is our hardware. That's actually one of our racks, and you can see that most of that stuff in there is Dell. And because we don't take care of physical security, that's the actual keys to these things, because the rack has a door. We're currently moving away from Dell. Dell is known to all of you, a pretty big vendor. And the problem there is that however large you get, it's very unlikely that you get to a size that a hardware vendor will talk to you. They're not going to really talk to you. They're going to sell something to you, but there's no way you can influence anything how they build it. And we've made some really bad experience with Dell in that sense. And so basically, we decided when we started doing this. Here's another view to that. When we started building that, we look for standards conformance, affordability, and simplicity in the components. We don't buy these huge blade center thingies or modular server stuff, because you then always buy into another company's platform that if they change something, then you can just go ahead and say, well, I'm going to do something else, because you have this huge buy-in into their technology. So we just buy the regular pizza box things and are happy with that. We basically only have four machine types. We have routers, like two of these. They're very simple Linux boxes. We have storage servers. That's where virtual machine disks go. We have virtualization servers, and we have backup servers that have a little bit more hard drives. That's all the hardware we have. We keep down the profiles. We buy them just by the dozen, more or less. We just keep reiterating another one of these, another one of these, another one of these. And the actual specs for these, they only change very, very slowly, maybe once a year, once every 2 years. We might buy bigger CPUs or bigger RAM or whatever, but we keep buying the same hardware. So we accumulate the knowledge of, okay, how does our environment on the hardware level work? And it doesn't vary that much. Right, and we actually found a really nice small German manufacturer called Thomas Krenn. They just built these super micro boxes, and they're just really nice people. And when you call them, they actually have knowledgeable engineers on their phone. That's really weird. They actually call you back and tell you that you made a weird config that they're building right now, if they should do the right thing, and you tell them yes, please, of course. That's very nice. So if somebody is looking for a hardware vendor, I could recommend Thomas Krenn. On the network level. Same thing there. We try to get affordable stuff that just does the right thing, that is standards based. And we looked around a lot, and we ended up buying HP ProCurve. When I was looking around, I always heard bad things about all of the network vendors. The worst thing I heard about HP is that they're like lice, the stuff that goes into your hair, because you don't get rid of them. But the thing is, actually, it's not that bad because you don't want it. They're very standards based, and it's pretty affordable. That's nice for us. And as we're now moving from Dell to Thomas Krenn with the hardware, the nice thing is we don't have to do a big change, because our spec is so generic of a few CPUs, disks, controller, this or that. We just start buying more or less the same spec from a different vendor, and it just nicely moves over, and we just fade out the old machines slowly. So the next thing is actually three things coupled. I didn't split these up. If you have hardware, then you don't want to run any services on top of that. We actually nowadays want to put stuff into virtualization, and the topic of OS and component selection goes in there as well. So one thing is virtualization is affordable from all perspectives, from money perspective, resource perspective, whatever. We run everything in a virtualized environment, and we actually feel the pain for like all the remnants that we have, all the residual things that still run on hardware. These are the things that still hurt when something goes wrong. Virtualization is really, really nice. And this is the point where we started thinking when we built this, oh, this is becoming a platform. This is becoming something where we say, this is what the application people start seeing. They start seeing a virtualized environment that's always the same. It doesn't matter whether we keep changing boxes. We even don't have to tell them. There's the virtual machine. It's the same as yesterday, and there's an operating system that In our case, we use Gentoo Linux, and there's a couple of building blocks that you typically need, like Nginx in a good configuration, or Postgres, or these kinds of things. And the customers actually don't get, that's why the OS is completely blue, the customers don't get root access. We do finely controlled sudo access that you can change Nginx configs to make a virtual host and then sudo reload this thing, but the OS is what we maintain, and we like to have a clear defined gray area, and that's that one where we say the components may be installed by us, but you can still change something. And these are very well-defined spots where we know that both parties, our infrastructure people or the application developer, can go in and change something. But these are only a few things. Right. Something we also noticed is that we go and make small VMs, and lots of them. We rather have, we run all of them in 32-bit actually, to force people to have smaller applications, but more of them. Especially with Zope, and Steve showed that, and Zio. I rather run, if I have 10 gigabytes of memory, I rather run 5 separate VMs with 2 gigabytes and 5 Zope servers, each of them with their own CPU, than have a single one with 10 gigabytes, because that won't scale on the CPU access. And it also makes the infrastructure, it gives the infrastructure the ability to change things underneath. It's much easier to do migration things and shutting one machine down and taking another up when you have multiple moving pieces that can fail over for each other. So all of these are always interdependent variables. You can't just change one thing. You can't just say I want more RAM, because then you notice, well, the RAM is now there, but I don't have enough CPU power to actually leverage that. And then you put in more CPU and you notice, well, now I'm network bound. So you always have to deal with all the variables. And we try to always make all the pieces as small as possible. So when that happens, when you have many smaller pieces, something else is what you need, something else to deal with that, and that's automation. Most of you probably heard of that already from the DevOps people. We use Puppet, and the actual requirement that we have for automation is that the system is convergent and idempotent. Convergent means that it doesn't require an expected state to start working. It can start in any state. You describe the target state, and it moves it where it needs to be. This has the benefit that if it meets an empty system, it just starts setting stuff up. Or if it meets a broken system because of configuration drift or entropy, then it moves it back to where it should be. And this paired together with idempotency, the ability to rerun the code all the time, and if nothing needs to be changed, then nothing changes. This is what makes configuration management, automating configuration management, very, very easy. Obviously, we want to version everything. We want to be able to have a testing environment, a laboratory where we can start exercising the changes and then move it over to a staging environment and then to production. We want to be able to see if something on the infrastructure level goes wrong and we notice, hey, performance was much better 2 weeks ago. What did we change in the last 2 weeks? Then we want to be able to see what happened. Also, everything should be code. We don't want to do any change manually. We currently have a team of 3.5 people that manage a few hundred VMs and a couple of dozen of physical boxes. If we need to change any config file manually, we're just basically out of business because that would take ages. And the tools are there nowadays. There's one thing that doesn't work yet. And probably that's an NP hard thingy in the sense that there won't be a trivial solution to it. It's called unmanaging things. When you describe target state, and you want to stop doing something, then you have to explicitly describe the I want to stop doing it state. If you just stop mentioning your target state, then obviously the system is just not going to care about it anymore. So for example, You might manage a system and say, I want this user to be present. If you then stop saying, I want this user to be present, that's not the same thing as saying, I want the user to go away. You just stop making it explicit that you want it to be there. So there is no general answer to, okay, how can I click a button and inverse whatever target state I described before? That's something to keep in your head. And obviously Python is in there as well. We've got lots of glue code that sits in there. This is currently triggered by cron that runs on a short cycle, and this is for moving parts. Like I need a new user, or that user needs more permissions, things like that, and that goes on a 5-minute cycle. Something we think about is moving that to a message queue-based thing where we can actually trigger. Where change can trigger a message to all systems. The systems can see, does that affect me, and then actually apply the change and go away from the polling mechanism. Because polling has the huge problem that if you have lots and lots of machines, and we've got a couple of hundred, that means there is one central point, like our config database, that gets talked to a lot, even though nothing changed, and that's just annoying. We're almost done with the platform. Management is the next thing. Traditionally, management in operations means that someone takes over the responsibility for a machine, and that's a good thing. There should be somebody who takes over responsibility. However, with the regular hardware and normal processes that we know from 5 to 10 years, and even in larger companies still nowadays, that's an either-or approach. It's either I manage something or you. Either I manage Apache or you, but I don't manage Apache if you change the virtual host, for example. And this is something that we want to break up. And the modern tools actually allow that very, very nicely by having kinds of like snippet directories where people can put parts of the config file. And Nginx, as one example, has the ability to guarantee that it does not fail when it reloads the config. It's just going to stop and not load it rather than crashing. Apache, on the other hand, is one thing that tends to not predict that very well. So, right, the other stuff that we expect from the platform is all these nitty-gritty day-to-day operations. Steve already mentioned backup and log rotation, all these kinds of things. And as a developer, you actually don't want to get back to this topic all the time. This is very mechanical, and you just want this solved. And so this is why we say, it's confusing. I've got this presenter notes, and I see stuff you don't see. The components that have this blue and green area, that's where we say, hey, we install a component, we make sure it's monitored, we're going to take care for the log rotation of these kinds of things, and then there's the plugin point for application developers that can say, here's my part of the config that I need to go in there, but I don't have to take care of all of that. And we actually consider that to be a gradual moving process. Unix is very nice in the sense that if we don't provide something on the platform or infrastructure level, then any user can just go and compile their own. You can just go ahead and compile it and run it, and it's like nothing stopping you from doing that. And when we notice that, hey, we have multiple projects that do the same thing, then okay, let's extract that. Let's extract that and use that and make it reusable for all of them, so they don't have to do all of these things like monitoring and stuff like that. And the last thing that, almost the last thing, I get confused. Monitoring, this is basically the operations part of if it doesn't have tests, it's broken. If it doesn't have monitoring, then it's broken as well. Unfortunately, there's Nagios. It's good enough for using it nowadays, but whoever noticed that last year, this hashtag came up, monitoring sucks, some guy on the internet yelling shit, and actually many people agreed, and many people are currently experimenting with newer solutions that are better than Nagios. But it does its job, and right now it's a good answer to start with if you're looking for something. There's a utility called PNP for Nagios that can graph things in the Nagios typical 5-minute interval. And the config management that we do has the ability to then just go ahead and add like 70 checks or something for each virtual machine that you go in and see. And that's actually very nice to rely on without having to manually do that, because you're going to forget that anyway. Um, right. Last thing for platform, until we come to the application thing, is support. Support is something that you should plan for as well. We did that on an ad hoc fashion before we switched our minds, and you need to have a help desk that ensures that any inquiries will be responded in a timely manner. That doesn't have to be an explicit SLA or something, but we made it a habit that we have a daily review that goes through all of our open tickets, and this is a very typical agile process thing, right? And like a stand-up meeting for support. We go through all the open tickets, we figure out, do we need to work on them today or not, and does the customer need a response? And this isn't really hard, especially if you do that continuously. Then there's mostly like 1, 2, 3, 4, 5 tickets that you're gonna see, and then you go back and do whatever work you wanted to do. The second thing is the so-called interrupt shield. It's if you have lots of customers coming in, like something in the infrastructure might be broken and many people having problems, then they start pouring in, and you have the danger of staying busy with telling people, yeah, we're working on it, but you aren't actually working on it. You're just telling people that you want to work on it, but they keep asking you. And like, so a technique that is good there is the interrupt shield. That means if you have multiple people, one person gets the shield, and they are the ones that get interrupted, and everybody else doesn't get interrupted. Everybody else does the work, and only one person keeps going back and forth. A tool for that, we use Request Tracker. There's Open OTRS is a similar thing, I guess, and a lot of custom glue code to actually make these processes automated again. Like when we close a ticket and put a date on it when we want to see it again because the customer didn't respond to that, then I want this thing to open up automatically. There's lots of small things that you can use Python for to automate, and then just make stuff in your processes go very, very well, so you don't have to spend man hours to hunt those tickets. Okay. I want to wrap that part up. That's what we consider a platform. That's when we do application deployments, that's what we take as a given. That's what we don't want our developers to have to take care of. And we consider this to be kind of a common meeting ground. It's where both the infrastructure people and the application people can go, and both have their area of expertise, and they both have their rhythm of working, and they both make the world better every day. And I find this to be much more attractive than the classical, hey, I wrote the software and you run it part. Let's look into the application part. So many things are covered by the infrastructure, luckily. However, there's still quite a lot of stuff left for the developers. I just noticed that my clock is wrong.
It's 14:29.
Okay, thank you. And there's still a lot of work left for developers. One thing is you need to figure out how your software actually makes it to the platform, to the infrastructure. And my requirement for deployments is that it should be quick. When I say I want the update to be out there, then I don't want to wait half a day or something. I want to press the button. I want it to go out. I want it to be repeatable. I want to be able to restore whatever state if something fails. I want to be able to repeat the config that's outside on my own machine. I want it to be platform independent. I want to be able to run on Amazon today and run on something else tomorrow. And single click, I already said that. This space is actually pretty dynamic. There's lots of stuff going on. There's the Juju people, there's Salt Stack, there's something that the Puppet people use. There's lots of stuff going on. We just keep refactoring the tools that we have, and we currently have something that's called Plateau. This is something I'd like to just skim over, save some time. It's an open source project that grew out of Fabric, and it's model driven, a little bit like Puppet, and we find it to be very nice. It's all Python, looks like this, where you just say, hey, I've got an address here, and I've got a buildout that should run with Python 2.7, and this is a program that should be picked up by a supervisor, and then this thing, the only thing you do is for a specific environment, you say, these are the machines, these are the components, do whatever you need to do that. All right, if somebody's interested in that, I'm gonna use printing on that thing, and I can show that around if people are interested in something better than Fabric, if they're coming from Fabric background. So that's how you get your software there. You need some tool to do that. I would recommend looking into this. There's good components and there's bad components. These are the good ones. If you have anything where those have in their title a description, if you have any requirement where their description mentions an overlapping word that isn't a stop word, then just use it. The bad ones, I'd recommend to stay away if possible. MySQL and BDB are my favorite. That's the rent part. They come from a company that manages to have 3 broken databases in their portfolio.
Oracle really.
Yeah, I didn't say that. I didn't say Oracle. Open LDAP is getting a little bit better. My biggest point with Open LDAP was that they're using BDB, and that can be a real pain. Apache has one problem that keeps annoying me, is that they have the graceful check, they have the config test, and the graceful command, and the graceful command does not work. End of story. Config test can tell you that the config is okay, and graceful will make the server crash. Happens. There's lots of ways to do that. It's just, for me, that's a no-go. I can't operate with that kind of equipment. If you know what you're using, which components, here's our minimal production-ready checklist. You need a sane front-end configuration, meaning do not listen on wildcards. Never listen on wildcards. Always listen on specific IP addresses, and make sure that you have canonical URLs. If you have lots of domains, lots of hostings, etc., make sure that you sanitize these, that you go back to a single URL space that is canonical. You need to think about integrating a system startup shutdown. You need to have log rotation in place, database maintenance that includes packing, generally dealing with growing data. That's like packing and log rotation. When Steven said that your server is going to die, it's basically because you have ends that start consuming resources and leaking, and you need to clean this up, otherwise it's going to die. You should have monitoring, at least for open processes and for running processes and open ports. We actually, when we are using supervisor, and the processes thing became simpler when you just start monitoring supervisor and asking it, is everything that should be running? That makes this part a lot simpler. And obviously put everything in a service user. And that again is something where if you do this separation between the platform and the application, just make it a platform task to always have a service user around. And then it's not a thing of, I didn't think of it and it was so much work. Just make it a rule, automate it, and then it's good. Hello? Another topic that you need to think about is how you get your secrets on the target machines. If you want your deployments to be single click, that's kind of hard because you're going to have SSL certificates, you're going to have database passwords, you're going to have things like that. And here's something how we figured out how to do that. We create one config file, the ini style thingy, per environment, so for staging and production and developers. We AES encrypt it. There's a nice utility called AES pipe that you just pipe it. You give it a key and you pipe something in and something encrypted comes out of it. And we wrote a safety belt, basically an edit wrapper like cron-tab-e or something like that, where it makes sure that the unencrypted files that you edit doesn't end up in your check-in accidentally. But this actually gives us the ability to check in all the secrets with our deployment code, so that even if we actually have an empty system, we can always recreate the whole thing. And the only thing we do is, when running, we have to enter the passphrase, and then the thing goes off. A little bit better, that's the next step, would be to turn this over to PGP, so that you create an encrypted version of the file for each developer that should be able to do deployments, and then re-encrypt it all the time for all the keys. And if you want to kick somebody out, just take out the key, re-encrypt, and you can't get to that stuff anymore. So I wrote some tooling for our utility for that. You should think in environments. You should think that you have your software actually running multiple times in staging, and actually development is on your machine is an environment as well. And these should be structurally identical and just from a resource perspective smaller. And if you do this whole configuration thing, then it's easy to, at least, you don't want to run the whole stack on your own machine. You don't run Nginx and HR proxy and these things. I can understand that. But what you should be able to is that you at least create the config files that would go on your machine and have a look at it, whether all the automation code and stuff actually does the right thing. And very important, Benji York said that is why all of this should be managed with the same utility. When you do that, is fly what you test and test what you fly. If you create too much specific stuff in the test environment, then it doesn't really, it's not a prediction anymore of what will happen in production. And here's a couple of notes on web application. Shared nothing, shared nothing, shared nothing. If I hear sticky sessions, it makes me cringe. Put your sessions in Memcache or something else. Don't make it a requirement that you hit a specific server, a specific app server. You should be able to hit any application server, and they should not have something like a shared file system or things like that. Make many, many small processes. As I said, we force them into a 32-bit system, and we also run one VM, one CPU, one process, one thread. This makes scaling much easier. It also makes much easier to see what's going on in the VM. If the VM is only running really one process and you're trying to figure out why is it consuming so much CPU, well, it's likely that it's the process you're running there, not 1 out of 20. And you don't get thrashing, and you can much easier figure out what's wrong in a system. Another thing is don't listen early, and this should actually become in ZOP 2 or ZOP 4. This should become a default. Open the network ports as late as possible. If you open a port to the network, your application should be ready to perform work. Best thing I could wish for is if we had something that would actually warm up the ZDB cache before opening the port. That's my wish list. Somebody build that, please. Runtime config should never go into the database. The CMF has been a bad idle in that respect. If you store config in the database, then it's really hard to just do a deployment that runs without activating the software to change the settings. So you actually start up with the old settings, and then you have to go in and change the settings. It's just annoying. I force this up all the time to write event listeners to read the actual config from the zopconf and then transfer that while starting up into the database to make sure that when the app is up, all the new settings are already there. All right. Replications 2, log long-running requests. There's a product called Long Request Logger. This takes continuous snapshots of requests that take too long, and this is very, very helpful to figure out, for example, whether you're spending your time in Zio or fetching an RSS feed or something else. This is whenever something is slow and you have requests that take ages, this is the thing that really helps debugging it. Corollary to that, just avoid synchronous external requests. Just don't do it. Also avoid accidental write requests. Supposedly Archetype is really good doing that. If a request is just reading data, there should be no write request to the database. And here's something that is useful also is feature switches. And this is kind of a contradiction to the no configuration in the database. A feature switch is something that at runtime, without restarting stuff, disables things that are broken, for example. Or if you hit high load and you notice that, oh, our Twitter portlet is always crashing under high load, then make it a switch that you can at runtime turn off and say, okay, now we're going to run without Twitter for a while, but our main content is still there. Process control. I recommend Supervisor. You can even, with the existing recipes, there's a specific command called console. You run zopctl or instance, however your recipe set up with fg or start, and there's a specific version of the command called console, which runs it in the foreground but doesn't activate the debug mode, and that's what you can use for integrating to Supervisor easily. This thing is similar to ZDaemon in that sense, turns anything into a daemon. And I recommend that you use SuperLens. It has a plugin for checking how much memory a process is using and then restarting it if it goes over a limit. And you should set that limit so that it triggers before Python sees memory errors. Because when Python sees memory errors, your processes get stuck in weird ways, and then you have to go in manually and restart it. And the HTTP OK check for making sure that if a process becomes unresponsive, then you also restart it. I do not like environments where this happens a lot, but this is just a band-aid to keep going until you have the time to actually look into it. This shouldn't happen under normal conditions. When you look at using Supervisor, use the 3.0 release candidate. It's pretty stable. It hasn't been changed in years, and Chris McDonald should be fed for releasing it. Buy him a beer, something like that. When you deal with Python, most of you deal with Buildout. Use virtualenv and Buildout combined. And the only thing I have to say, the biggest thing I have to say about Buildout is it's a hammer. It might be a hammer, but not everything is a nail. I see too much abuse about what people do with Buildout. Really use it to configure Python environments. That's basically what it's good for. And don't. Yeah, if I see a compile running from Buildout, I cringe as well. Use extends. Don't build huge single Buildout config files. Split them up in smaller parts. They're really easy to stack and to have these diamond-shaped things where you can make the structure really readable. Always set allow picked versions false. This should be the default. Set when you run it, give it a timeout of like 3 seconds. Otherwise, if PyPy is down, you won't notice until, well, you come back from getting your coffee and it's still sitting there. Buildout should be the newest version, 1.6. Both 1.5 and 1.6, they have really good performance enhancements. You should be using those. Mr. Developer is a really good utility to work temporarily on stuff, but it should not appear in production. When I see that in production, I just shut down everything. And the allowed, yeah, you. He knows it's not true. and excellent. Combined with the -t option, use allowed hosts. Do not let Buildout go to random places on the internet. Force it to if you have a local PyPy mirror, then use that and then tell it to only go there. And it's going to fail hard and fast and telling you, oh, I tried going there, but I couldn't, and I don't know where to get this egg. This is really good when PyPy hangs or something's wrong in the network to fail early. Also, that's something we do with Plateau when we automate that shit. We rather make multiple small build-outs, one for Zio, one for Zope, one for supervisors, because you can use different Python versions, you can use different subsets of eggs, everything because of the graph algorithms and the dependencies and such becomes much faster anyway. And I already said, PyPy mirrors, there's a nice page that lists all the mirrors that are actually there with the reliability and the performance and stuff like that. And actually, the latency to your PyPy mirror is, if you don't do things like compile stuff, the actual getting the egg environment set up, latency to the PyPy mirror is the one biggest thing influencing Buildout runs. If you can get that faster, that can make it orders of magnitudes faster. All databases, not just Zio, as much RAM as you can afford. For Zio servers, I try to get as much RAM as the data FS size. I want this thing to be in the disk cache. Because what happens is, if you have the whole database in the disk cache, this eliminates any read requests on the disk, which means that write requests actually become a lot faster because they don't have to intermingle with any read requests. So if you can afford that, that's really nice. Your network that databases run on should have a consistent latency of less than 100 microseconds. Everything beyond that, if you look at Zio, 100 microseconds means you're able to load, how many is that? 10,000 objects per second. And that's only on the network. So if you have to compute in between, then you're already talking about at most 5,000 objects per second. And who knows how many objects are loaded on their own Plone front page? Loading for the first time. I regularly meet when coming up cold, I meet 30 to 40,000 objects on the first page. So that means that if you have to go to the Zio server for 40,000, that's 10 seconds just spent on the network. You can go down to less than 100 microseconds affordably, and you should watch out for that. Multicore for databases if necessary. Postgres uses this very, very nicely. That's one of the spots where we do use multicore. And you should plan for disk usage less than 40%. If you do have to do a disaster recovery or something, then you probably have a file system that still has the old data in place, and you need enough space to put in the backup database next to it before actually restoring. Also, if you pack, consider that in the worst case, it has both databases on the disk as well. So database servers should have disk usage less than 40%. I'm going to go over that story. Whoever wants to know how more hardware makes stuff slower can talk to me. The important part of this killed an application just by buying more RAM. Really nice. HTTPS, Nginx was already mentioned. It's for HTTP and HTTPS. Those things, that's what it's good for. Use it for that. Don't put that in your application. Load balancing. I prefer the strategy least con. As Steve said, load balancing is there to make sure that there's somebody available to serve you, and least con does exactly this. It's going to give you, if you combine this with only ever give one request to one machine, then you will always, as long as you have somebody free, then it's going to end up on the free one. Combined with redispatch and retries, we don't even signal HA proxy to shut down stuff. We just let it run. We just let it have a request go to a dead backend, figure out, oh, it's dead, go to another one, mark it dead, and all's good. I don't mingle with that. This thing just runs, and it's really nice in the statistics UI to see what's going on. It's really nice in the logging to see for each single request which timing was in the front-end queue, the server queue, the pools, waiting for the backend server, how long it took to deliver, how many other requests were in which queue at that point. Really nice to figure out performance problems. Again, I said monitoring processes, ports, and logs. Model dependencies. If you're using Nagios and you have many checks, make sure that you model the dependencies, because otherwise if something goes red and you're reading emails, you're getting all the stuff that's red. But if my router goes down, then there's no point in you reading through all the 100 million mails that go there. I just want to get notified and said, hey, the router's down, and everything else behind it obviously as well. There's a really nice tool called check web page RB, obviously a Ruby thing that can fetch without too many external dependencies and stuff like Selenium things. It fetches a page, follows redirects, looks into the HTML and fetches all the resources and tells you, oh, this took too long, or there were broken resources in there, stuff like that. This is really nice. And an add-on that I can recommend is the business process thing, where you can aggregate multiple checks and say, well, I only want to get informed if 4 out of the 10 Zio servers are down. There's 2 implementations. One is the Nagios business process add-on, and one that is a weird Perl thingy that runs within Nagios and it's just weird. And the other is the BPI one. Both are basically even worse than Nagios itself, but they do their job. If you're running an application, you should also be doing reporting to your customer. Our customers require it, and I'm actually happy to do that. If they want to report, they get that, but then I also get a phone call. I do not write reports if I do not get to talk to the customer about the report. If the customer doesn't want to spend the time to talk to me about what I wrote in the report, then I don't write it. I think you agree. Amen. In the report, you should be listing incidents, what happened, and you should aggressively be listing everything that happened, all the small shit. First, the customer sees what's going on. That makes you actually have to do your job to make sure that all these little things don't happen. And it shows the customer where you spend the time and where stuff is improving. Anything you change, you should talk about to the customer. You should say, we changed it, it became better, it didn't become better. You should show the availability and say, like, well, we were down because of this, we were down because of this, or hey, we planned to be down, but we weren't. It was just a minute instead of 10 minutes. You should be talking about performance, and you should take all of these things that you have and look at the longer picture. You should look back and say, well, half a year ago we had this issue, and as you can see, when we made that change half a year ago, that became much better, and we can now handle the traffic in a much better way. These are the things that we put in there.
You've got about 10 minutes left.
Excellent. I shouldn't have hurried. Excellent. Then let's talk about SLAs, and this is something that overlaps into high availability. You want more availability because that keeps your business safe. You stay in business if you're available. If you accept less availability, you can save some money. The point with SLAs is you make an agreement with the customer where you put down objective numbers for what you agree upon. And what we found, even with very, very strict requirements, is that it's basically not that you're going to get fired if something bad happens. It's about clearing up the expectations from both sides and having something to talk about how to deal with it in the future. And if somebody asks me what the availability level should be, then the answer is as much as you can afford. and as much as makes you save money by spending. So if somebody says, well, we need 99.999% uptime, then I ask him, okay, how much is that? And nobody really knows. I can't even remember. That's why I say don't think in nines. So let's see, 99% is 87 hours of downtime per year. And the per year thing is already part of the problem. That means I can take 87 hours at once and still meet my SLA goal. So we typically agree on a monthly and a yearly goal, sometimes even daily. 99.9%, that would be 8 hours per year. And that is actually pretty hard. So 99%, 87 hours per year, that's pretty easy to do. That's if you don't do too much bad things, and then that's just okay. 8 hours per year of downtime as a guarantee is already really hard. We meet that. I think the best service availability we had last year was actually 4 nines plus a 7. But that's not what we guarantee. We actually usually guarantee 99.5 or something like that. That would be 18, 20 hours, something like that, per year. And if somebody comes with 4 nines, that's 45 minutes per year. And the problem there is that people only think in nines, and they add a 9 in the end, and it's like, hey, that's just one more 9. But the problem is it's an exponential thing. Every 9 makes it exponentially more harder to meet. So that's why I recommend talk to them about in hours of downtime per day, week, month, what's acceptable. And then when they try to find how much they want, when you try to agree on how much they want, you need to ask them, well, how much does it cost you to be down for this time? And that's very easy. Usually they don't know, and then make them guess and go back and forth a little bit and just think about it really hard. Actually, this is good advice, I think. The thing is, most people can't put a number on it. We have a couple of customers who can tell us that half an hour of downtime costs them 50,000 euros. And then it's very easy to spend 20,000 euros per month to avoid this half hour. It's very easy because they're saving money, because they had a baseline where they were down for like 4 hours per month, costing them like €500,000 or something like that. And then making them spend 20,000 euros is just a no-brainer if they can save $500,000. And the point here is that it's not just technical. We do almost no classical high availability stuff in the sense of like having redundant Zio servers or things like that, because our downtime requirements allow us to have like an hour of downtime in between, fix stuff, and then get back. That's enough time to shut down the VM, move it to some other server, get stuff out of the backup or things like that. That's not where I need to have complicated setups. As Steve said, try to keep it simple. And I rather solve these issues on an abstraction level like virtualization than make the Zio setup much more complex. And we rather put more time into organizational measures. So if somebody says that they want to have only 1 hour of downtime per month, then I say, okay, you've got to book me 24/7 with a response time of 15 minutes. Because if this happens twice, then I have 15 minutes to alert myself, get to the server, fix something within 15 minutes. I can do that twice per month to meet the SLA. If that would happen the third time, the SLA would be gone already. So if you don't combine the technical measures with organizational measures guaranteeing you to, if there's a failure or something, to actually have a person there taking care of it, then all the failover doesn't help. Failover and HA is really only there to make sure you buy a little more time to get your personnel in and start fixing the actual problem. Okay, that's actually the content I have. There's 3 things I want to recommend. This is our Bible. I recommend go out and buy that. It's like 5 kilograms of paper or something like that. So the electronic version is much better. These are really good sysadmins. They know their stuff. They know how to do things with 1 computer and thousands. And it's just very, very nice. And they even tell you how to get your glasses out of your dishwasher without stain. Mark Burgess, he's the guy from CF Engine. He wrote a couple of really, really good articles about special relativity of distributed systems and stuff. That's actually about config management, really nice. Heroku has a good document explaining how they think their platform and their approach to application deployment, the 12-factor app. And we've got our documentation online. Okay, let's wrap that up. A few conclusions. We use infrastructure to build platforms, and platforms should be transparent in the way that that's what the application people and the infrastructure people see. That's where they can meet. That's where they can talk to each other. And you should only deploy application on platforms. If you deploy on Iron, if you deploy on somewhere, then you're holding it wrong. Don't cobble together random stuff. This is really, really dangerous. Really, the components we end up with, they're always the same. It's always Nginx, HA proxy. These things are really, really proven. Careful work pays. That was one of the conclusions from the analyzing why did this thing get slower when we put in more RAM. It's careful work that makes you figure stuff out. Buzzwords doesn't help. If you hear enterprise, run as fast as you can. And enterprise.
Go, run.
Ah! Thank you. Yeah. And use your brain. Use your brain. The point where we are currently at, when we started building all that stuff, I wasn't satisfied with the idea of infrastructure as a service or platform as a service. Infrastructure as a service still makes me do all the platform work. Like when I get Amazon stuff, I still have to figure out networking, I still have to figure out the operating system, all these kinds of things. But I lose all the fine-grained control of what's going on underneath it. I have to deal with all that intransparent stuff that's going on behind the virtual machines. Platform as a service is, in the sense of Google and Heroku, I find these to be way too limited for these kinds of projects that we have, where we have to have the ability to take random software and just stick it in there and run it. And many people are currently experimenting in that space, and I think there should be more experiments along the classic Unix traditions, and everything's becoming more flexible, and that's really, really nice. And play with that. Yeah, questions? Okay, I overran you. This was a high-pressure talk.
I have a very specific one. You mentioned don't share anything. How do you do for blobs?
What's the problem? Blobs are sitting on the Zio server, right? Yep.
You mentioned about sessions
Mhm.
in Memcache.
Yep.
Question about sessions for anonymous users.
Yep.
Have you ever been tried to solve this problem, or you shouldn't have sessions for anonymous users?
What's the problem? They go into Memcache, yeah?
The problem is you actually can't set session for anonymous user without giving the fresh response each time. So you have to.
Oh, you're talking about caching, is it?
Yeah.
You're not talking about the sessions itself, you're talking about caching in Varnish or something like that?
Yes, if sessions have been generated, say on the website,
Mm-hmm.
like people,
Mm-hmm.
then you have to provide fresh response.
Right. So the problem is this: you usually have cookies, and as Steve said, if you do caching, you do it very, very conservatively first. So Varnish in the default config correctly will not cache anything that has a cookie. And if we know how to be more careful with that, we go into the cookie and actually take parts out of the cookie to make Varnish compute a more specific cache key, so we actually can say, okay, we know you can ignore this part of the cookie and this and this. Sessions will probably mean that you will not get cached, yeah. Which is, right, and I saw.
About your particular project.
Yeah.
How did you solve that?
One thing is that we have to avoid initializing sessions when you don't need them. So, for example, Plone tends to, I'm not sure whether I'm lying because these are details that I don't know from the top of my head anymore. Plone, I saw Plone in some versions start a session for anonymous users the moment you hit the homepage, even though there's nothing in there. You have to avoid that. You have to only initialize sessions when you actually need them.
You can also get around sessions with modern content technology.
Yeah, that's or get rid of sessions at all. Yeah, yeah, yeah. Right. Browser storage is better today, depending on your customer. Yeah, yeah, yeah.
Just about storing something on server side, not on the client side.
Depends on your application.
It depends. It depends. It's just another option. Yeah.
Client store balance
Yeah.
here.
Yeah.
Okay.
I guess we have to wrap up.
Okay. Sure.
Continue in the break.
Thanks for your time. And if you want to see more of the deployment automation thing that I have, I'd be happy to have an open space or see you at the sprint or something like that.